Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be learning how to compute the volume of prisms and pyramids. Don't forget we have some practice problems at the end of this presentation for you to try out in order to demonstrate mastery of the contents of this presentation. To get us started, let's take a look at the formulas for finding the volumes of prisms and pyramids. Okay, so let's start with the formula for finding the volumes of prisms. So volumes of prisms. The formula for finding the volume of prisms is as follows. The volume V is equal to the area of the base multiplied by the height. Okay? So remember, when you have a prism, the top and bottom bases are identical polygons, so it doesn't really matter which shape you select. And you just multiply by the height, the perpendicular height between the two bases. All right, so let's write this down. This can be broken further into V equals the area of the base, that is what big B is, multiplied by the height of the solid. So something to keep in mind is that the base could have its own height too. So you need to distinguish between the height of the solid and the height of the base. For example, if you have a triangular base or a trapezoidal base, for example, you're going to have two heights, which we'll see in example 1. All right, let's take a look at volumes of pyramids. What is the formula for that? Formula for volumes of pyramids is as follows. Volume of pyramids is simply a third of the volume of the related prism. So a third of the base, area of the base times the height. Okay, so V is equal to 1/3 times the area of the base, all right, multiplied by the perpendicular height from the base to the apex of the pyramid. All right, height of the solid. All right, so now let's take a look at the steps that are going to be guiding our problem solving process. So steps for finding the volume of prisms and pyramids. All right, so here are the steps. First of all, you have to write down the formula. That's your guide. You write down the formula for the volume of the solid that you want to determine the volume of. So to do that, you're going to have to identify the solid. Okay, so step number 1, you write down the formula by identifying the solid. So look at what kind of solid you have, and then you write down the formula. Okay. Step number 2, you're going to find, this one involves more work. You're going to focus on the base first. Okay, you find the area of the base. That's the one that involves a lot of work. In volumes of prisms and pyramids, the height is just a number. You don't have to do any work. But finding the area of the base involves most of the work. Okay, so you find the area of the base, which is big B, for both prisms and pyramids. And then next, determine the height of the solid. Very important. Remember, we talked about the possibility of there being two bases. So you got to determine the height of the solid. The height of the solid, we're going to call that big H. Little h is the variable reserved for the height of the base. Determine the height of a solid. And then step number 4, plug in values from step 2 and 3. Step 2 is the area of the base. Step 3 is the height of the solid into the first formula that we came up with in step number 1. So plugging values from step 2 and 3 into 1, the formula for the solid. All right, and then we plug that in, you just and then number 5, just basically simplify as much as you can. You're going to simplify that resulting expression using the order of operations. Please excuse my dear Aunt Sally. Alright, so let's go ahead and take a look at some examples. Alright, so the instructions for the examples we're working on are first to identify the given solids and find their volumes. Alright, so for question number 1, what kind of solid is this? Let's name it. So if you take a look at this solid, you can notice that we have 2 polygonal faces that are identical in shape, namely the ones on the left and the right. Okay, those are the bases. So whenever you have a polyhedron or a geometric solid where you have 2 identical bases on the top and the bottom, and the sides are parallelograms or rectangles, then that's a prism. Okay, the shape of the base will tell you what type of prism that it is. So this side right here, this shape right here, that's one of the base, that's the left base, and this is the other base right here. So what shape is that? You notice that they have 1 pair of parallel sides. So a polygon with 1 pair of parallel sides is called a trapezoid. All right, so if you put trapezoid and prism together, the name of the solid is a trapezoidal prism. Okay, so that will help us to determine what the right formula is. Okay, so now we're going to go ahead and find the volume. So find the volume. All right, so the steps are as follows. First of all, we want to specify what the formula is. So what is the formula? Well, depending on what we're dealing with a prism here. So the formula for the volume of prisms in general is big V equals big B times the perpendicular height h. All right, and we can break it down further. V is equal to big B is going to be the area of the trapezoidal base. That's what big B is. So V is equal to area of the trapezoidal base multiplied by the height of the solid. Height of the solid. Okay, so let's go ahead and move on to step number 2. So step number 2, we want to find the area of the base B. All right, so step 2, I'm going to find big B, which is the area of the base. Area of the base. So let's just sketch it here so that we can see exactly what we're dealing with. All right, so I'm just going to make a small little sketch here. We already talked about what kind of shape this is. It's kind of like an isosceles trapezoid. So just make a nice little sketch here. All right, so we can clearly see that the base is a trapezoid. We talked about that earlier. So if we put in the measures, this is 12. The upper side of the base is 12. This is 12 centimeters. And then the bottom is 6. And then this is 5.2. Okay, so what's the formula for the area of a trapezoid? That's a question. So the area of so big B is the area of a trapezoid, which is equal to 1/2 times A plus B times big H. That's the formula that we're going to be using. All right, this is the formula for the area of a trapezoid. All right, so this is big A right here. This is big B, little a, little b, and this is H. the perpendicular height between the two parallel sides. Okay, remember we talked about there being the possibility of there being multiple h's. So we can see we have a big H, the height of the solid, and we have a little h here, the height of the base. So this one is the height of the base. All right, so let's calculate the area of the base. Big B is going to be 1/2 of 12 plus 6 times 5.2. All right, so that gives us 1/2. We're going to use order of operations here, PEMDAS, to simplify this. Okay, so 12 plus 6 is 18 times 5.2. We can calculate what half of 18 is. Half of 18 is 9. All right, so 9 times 5.2. And then we'll multiply 9 by 5.2. We have 9 times 0.2 is 18, so 8 carry 1. 9 times 5 is 45, plus 1 is 46. So the area of the base, big B, is 46.8 centimeters square. Okay? So now that we've found the area of the base, we're now going to proceed to finish it off by determining what big H is, and then we'll proceed to find the volume of the solid. Okay, let's put a partition right here. Let's make it a broken line. All right, so scroll back up. So determine what big H is. Big H is the height of the trapezoidal prism. Okay, so remember this is A right here, A, which is equivalent to this. This is B. This is little h right here, little h. So the big H is the distance between the two bases, the two congruent polygonal bases, namely the trapezoid in this particular case. So what's the perpendicular distance between these two faces? Is this 18 value right here. You see this 18 value? That is the separation, the distance between this base right here and that base back there. That separation is 18. So this is 18, 18. This side right here is 18. All right. So that basically represents the height of the prism. If we stood this prism on its face, this would be how tall it is, 18 centimeters. All right. So big H, height of the prism, is 18 centimeters. All right. So now that we know what big H is and big B, 46.8, we can now plug in the two values into the original formula that we have. So let's write the original formula. Volume is equal to big B times H. All right. So big B, the area of the base, we found it before, is 46.8. And we're going to multiply that by the height of the solid, which is 18 centimeters. All right. So just simply carry out the multiplication and we'll get our final answer. The volume is going to be 842.4 centimeter cube. Okay, remember we're multiplying three lengths. Centimeter times centimeter times centimeter represents centimeter cube. Remember always that the area results in the square of the unit, and a volume results in the cube of the unit since it's three-dimensional. All right, let's take a look at question number 2. So we want to identify what the solid is, what this polyhedron is, and then find the volume. All right, so what is this called? What kind of solid is this? If you take a look at this solid, you notice that it has a polygonal base. This is the base right here. All right. And it has an apex or a top where all the sides that happen to be triangles all meet. A solid like this is called a pyramid. Okay, so a pyramid has a polygonal base made up of sides that are triangles that all meet at a point at the top called the apex of the pyramid. All right, so this is a pyramid. Now, what type of pyramid is this? Just refer to the base to determine what type of pyramid it is. Okay, so you notice that the sides are congruent. This is 7 meters, 7 meters. So it's equilateral. It's an equilateral quadrilateral since it has 4 sides, and then the 4 angles are also congruent. So it's equilateral and equiangular. It's a regular quadrilateral. So this base is a square. Okay, has a square base. So the name of this pyramid is a square pyramid. Square pyramid. All right, so now that we've identified what kind of solid this is, let's go ahead and find the volume. All right, so we're going to follow the same 5-step procedure that we used for number 1. Hopefully I have it written down. You can refer to it. So first of all, we have to write down the formula. Okay, V is equal to big B times, 1/3 of big B times H, because we're looking at a pyramid here. So it's a third of the volume of the related prism. 1/3 big B times H. Okay, so V is going to be 1/3. Big B is the area of the base. Okay, what kind of base do we have here? We have a square base. So big B is area of the square base. That's what big B is. And we're going to be multiplying that by the height, perpendicular height of the pyramid. Okay, and in this case, you see this segment right here, that's the perpendicular height, big H. All right, so let's do the first part, which is to find big B. Find big B, which is the area of the base. In this case, is a square base. Square base. Okay, so let's sketch the shape of the base. It's a square. So what is the formula for the area of a square with side length of 7? So let's write down what the area of a square is. So let's just write down the general formula. So let's say the side length, side measure is S. Okay, as a measure of a side. So what's the area of a square? So let's make it equilateral and equiangular. What's the area of a square with side length S? The area in this case is big B. So the area of a square which is big B in this case, is simply S raised to the second power, S squared. Okay, so in this problem, S has a value of 7, so it's going to be easy for us to calculate the area. So the area of the base, which is big B, is going to be 7 squared. 7 raised to the second power is 49. Bam, bam. Okay, so we found that big B, so let's move on to step number 3, which is to find what the height of the solid is. So H, the height of the square prism, square pyramid, H, we identified that earlier, is 8. Okay, that's the perpendicular distance from the base of the pyramid to the apex. It has to be perpendicular. All right, sometimes it's inside, but if it's tilted, it could be outside too. So the segment. So let's go ahead and determine what H is. H is 8 meters long. So the area of the base B is 49 meters square. The power is 2 because it's the area. H is 8. So now we can find the volume by plugging our answers from step 2, the area of the base, and step 3, the height, into step 1, which is the actual formula. So V, let's write the formula, is 1/3 big B times H. Put it all together. It's going to be 1/3 times big B, which is 49, times H, which is 8. If you carry out the computations with your calculator, you will get 130.66 repeating meter cubed as the volume of your square pyramid. Okay, so there goes your final answer for question number 2. All right, so here are some practice problems for you to try out. We'd like you to go ahead and pause the video presentation and attempt these 2 problems. Your task is to find the name of these 2 solids and then determine what their volumes are. Okay, when you're done, click on the playback button and we'll reveal what the correct answers are. All right, so hopefully you had a chance to try out the problems. So for the first one, column number 1, this solid right here is a triangular prism. And the volume V is 92.8 cubic kilometers. For the second one, this is clearly a pyramid since you have that base and the apex action happening. It's a 5-sided polygon as a base, so it's a pentagonal pyramid. And the volume of this solid is 330 kilometers cubed. All right, so there goes the answers to your practice problems. Thanks so much for taking the time to watch this presentation. Don't forget to support our channel with your likes, comments, and subscriptions. Tons of support resources can be found at mathgotserved.com. Do check it out. Have a wonderful day, and we'll see you in the next video. Goodbye.